Hello students and welcome to the lecture. So students, as we know that we have started the discussion over the physical and the world geography in the previous lecture, and that was the part 1 of that particular series, and now we have the part 2, okay, for the physical and the world geography. In part 1, we have seen the several things like about the universe, solar system, earth, interior of the earth and others. In this lecture, we are going to see about the atmosphere, the wind system, sources of water in the world, natural vegetation, and the mineral resources. Okay, so these are going to be the topics that we are going to discuss in this particular lecture. I hope you have revised the previous lecture in a well enough manner. Before you have come for this lecture, as many times I have told you, it is for your own good. If you are doing this on the regular basis, things will be in your favor. If you are not doing this, the thing might be difficult for you. So, before starting of this particular lecture, there is a small disclaimer. The images used in our slide deck are for educational purposes only. We respect the intellectual property rights of the original creators and the owners of these images. If you are the owner of any of the images used in this tag and have any concerns or issues, please contact us at sathee@iitk.ac.in and we shall remove the images. Now, let's come to the first topic of this lecture. So the first thing that we are going to talk about is atmosphere. Okay. So what do you mean by the atmosphere? It is the first thing. But before this thing, let me tell you one thing. Basically, when we talk about this, so atmos stands for the air. Sphere stands for the layer. Okay. So this is about the air layer. Okay. Similar things happen with the other parts of Earth. The Earth, for our understanding, has been divided into the three phases: atmosphere, lithosphere, and hydrosphere. Atmosphere is referring to the air and all. Lithosphere is referring to the land, and then comes the hydrosphere that refers to the water. Okay, so here we are going to talk about the atmosphere. It means that we are going to talk about the air layer and all. So if we talk about it, the vast expanse of air which envelops the earth all around is called the atmosphere. It means that if this is an earth, so the earth will be surrounding by this particular layer from all these sides. Okay, and here is one thing also: atmosphere, lithosphere, hydrosphere, when all these get combined, they forms the biosphere. Okay, so keep this thing in your mind. And if we talk about the width of that particular layer or the extent of that particular layer, so that particular layer even extend up to thousands of kilometers. It means that it will not start from somewhere this, but you can see this is the extent, and the topmost is the nearly about 10,000 kilometers. So now you can assume by yourself how vast is this layer. Okay. If we talk about what are the constituents of this particular, you can say layer. So the constituent of air in the atmosphere are generally the nitrogen, 78%, oxygen, 21%, argon, 0.93%, and carbon dioxide, 0.03%. Okay. The highest share is going to the nitrogen, followed by the oxygen, and then comes the argon and the carbon dioxide. Okay. Please correct this thing. the percentage of carbon dioxide is 0.04%, not 0.03%. You can see that this is varying from where you can say place to place whenever you search it. But the approx number that we considered usually is 0.04%. Okay. So beside these, water vapor, the dust particles, smoke, salts, and other type of impurities are also present in air, but their quantities are varying. It means that the quantity is not fixed. For example, the place that having a high temperature, on that place particularly the quantity of water vapor will be higher in comparison with the place that is having the moderate or the low temperature. What is the reason? Because whenever the temperature will be higher, automatically the water resources will have the evaporation, and that evaporation generate the water vapor in the air. Okay, so that's why higher the temperature, higher the number of water vapors. Lower the temperature, lower the number of water vapors. Okay, but this thing is only applicable when there are the sufficient water resources. Suppose you can say if you go to the desert, you will find the humidity is not that much of high as comparison with the temperature of that place. And if you follow the same rule, the higher the temperature, the higher the water vapor. So what you will find that basically temperature is going higher, but the water vapor quantity is not that much because there was a lack of water resources. So evaporation could not take place. And when the evaporation could not take place, automatically the quantity of water vapor would be reduced. Got it? That's the thing. Now let's move forward. Here we have the structure of the atmosphere. Like we can say, commonly we count atmosphere as a one layer. But deeply when we go inside, we will see that there is an division of the atmosphere itself. Okay. And the division is like, you can say, first is the troposphere. If we talk about the troposphere, so from Earth's surface, it extends up to 18 kilometers. It means 18 kilometers from the Earth's surface. What are the features of this layer? Basically, the 75% of gases are present in this particular layer of the atmosphere. Okay, so we can say out of the constituent, the highest percentage is found in troposphere. Okay, this contains the 75% of the gases in the atmosphere, and with the increasing in the height, the temperature decreases. Okay, temperature inversion. The temperature decreases by 6.5 degrees Celsius per kilometer extent. Okay, there comes the stratosphere. After it, it extends from 18 kilometers to up to 50 kilometers. Okay, and this layer is known to have the famous ozone layer. Okay, so what is the work of the ozone layer? Basically, we all know that the earth receives its light and energy from the sun. Okay, but the waves that we receive from the sun, okay, these waves containing some harmful UV rays, and these rays are not so good for the human life on Earth. So that's why the ozone layer that is present in this atmosphere through the stratosphere, this ozone layer basically reflected back that particular harmful UV rays, and that's how the UV rays are not that much reachable to us and we are safe here. Okay, and if we talk about the effect on temperature, then the temperature remains fairly constant, nearly about minus 16 degrees Celsius. Thereafter comes the mesosphere. Mesosphere is the middle layer. Okay, if you look at here, then meso means middle, sphere means layer, middle layer. Extend up to 50 kilometer to 80 kilometer. It is the coldest region of the atmosphere. Why? because the temperature drops to minus 0 degrees Celsius. Oh, sorry, minus 100 degrees Celsius. Okay. Here you can say this is the mesosphere, troposphere, then ozone, stratosphere, then mesosphere. Okay. So here you can see it. Thereafter comes the thermosphere, famously known as ionosphere also. This extends from 80 to 400 kilometers. And this is very important layer. Why? Because radio waves are bounced off the ions and reflect waves back to the earth. Like you can say, this thermosphere is having some ions in it. So whatever ray we use to the satellite, okay, the satellite reflect it back to the desired location. For example, we can have an example like someone is here, want to send message here. So he will send message on the upper side. Okay. The message will be received by thermosphere and reflected back to the earth on that point. So that's how the communication took place, and that's why we said that this particular layer is an important layer for the radio waves reflection and for the communication, like the radio communication. After this comes the exosphere, that is above 400 kilometers. Okay, like this one. This is an upper part of the exosphere that is called the magnetosphere. The temperature keeps on rising constantly at the higher rate. Okay, so we can say temperature falls down, falls down, falls down. Temperature rising up and rising up. Okay, this is the flow chart of the temperature. You can have this. All right. Now, let's move forward. So, the greenhouse gas, if we talk about the greenhouse effect, so the greenhouse gas is the gas in the atmosphere that absorbs and emits radiation within the thermal infrared range. That is 8 to 15 microns. Now here you can see it also, the greenhouse effect. So basically some solar radiation reflected back by the earth, alright. So the sun basically gives us the energy through the infrared radiation that passes through the atmosphere. Some is absorbed and re-emitted in all directions by the greenhouse gas molecules. And this effect of this is to warm the earth's surface and the lower atmosphere. Okay. So the amount of layer that has been sent from the earth, most of the radiation absorbed by the earth's surface and warms the surface. Okay. Thereafter, some of the infrared radiation emitted by the earth's surface and some of them basically reflected back from the atmosphere. Okay. But what happens generally, we can say in a short and a simple manner, the sun sends us the energy, we absorb it, utilize it, and then we reflect it back. Okay. So that is a thing. But when we talk about the greenhouse, then what happens? Basically, the greenhouse gases are well known for their trapping stage. It means that the radiations will come from the sun and could not go back because the greenhouse gases will absorb them, will keep them within the earth atmosphere, and that will automatically rising up the earth's temperature that is not so good. And if we talk about the primary greenhouse gases, then these are the water vapor, carbon dioxide, methane, nitrous oxide, and ozone. So we can say any gas or any gaseous substance that is having the capability to absorb the upcoming solar radiations. These all are the part of greenhouse gases because when they absorb the solar radiation, they trap them and not allow them to go back So that's how the temperature of the Earth's surface keeps on rising. Got it? Now, after finishing the atmosphere, we have the wind system. Okay. So what do we mean by wind system? So basically the pressure differences is the major cause of genesis of wind system. It means that like the wind always blow from high pressure to low pressure. Okay. It means that suppose if some place is having the high pressure and some place is having the low pressure, then the winds will always start moving from high to low pressure. Okay. And that's why it is said that the pressure difference is the major cause of the genesis. Genesis means generation of the wind system. The slope of pressure from high to low is always called a pressure gradient. Okay. And this could be also called as the barometric slope, because the high pressure and low pressure is often referred as atmospheric high pressure and atmospheric low pressure. Okay. Because in wind system also we deals with the air. So that's why we use the atmosphere named here. The direction of wind deviates from the expected one due to the Coriolis force caused by the rotation of the earth. You can say suppose if the air generated from here, okay, and going upside, then automatically the air will be reflected here. Similarly, if the air comes from here, then air will be reflected here. So you can say why this air reflected, because of the Coriolis force, because of the Coriolis force which is deviating their path, and this is because of the Earth's rotation on the regular basis. Okay. If we talk about the types of wind, so we have the different types of winds, and these are planetary wind, periodic wind, and the local wind. Planetary wind, if we talk about this, planetary winds throughout the year from one latitude to another in response to the latitudinal differences in air pressure, like trade winds, westerlies, and polar winds. It means that their path is always fixed. They always move in a one particular direction. Okay. That's why they are known as the planetary winds. Periodic winds. Periodic winds basically changes their direction of flow as per the periodic. It means that monsoon wind. If the monsoon season is here, then automatically the monsoon winds will come for the monsoon period. Land and sea breeze. It means during daytime, the wind blows from sea to the land, and during night time, the winds blows from land to sea. Okay. After this, we have the local winds. So the local winds develop as a result of the local differences in temperature, like the sea breeze and all. Okay. Local winds means the winds that are generally in flow because of the high and the low pressure. So three types of wind we have completed. Planetary winds, the winds that having a fixed path throughout the year and they do not change their path. Periodic winds, which flows only during the periodic time, okay, and changes their direction as per the periodics. Local winds, these winds are the winds that generally you can say develop due to the high and the low pressure. Now we have the local winds. Name and the nature of it. First is the Chinook. What is the nature? So Chinook is a hot dry wind which found in Rockies, and these are also called the snow eater. Okay, because these are hot and dry, and Rockies mountains covered by the you can say snow during the winter time. So when the Chinook winds blows, so basically it melts the snow. That's why it's known as the snow eater. Thereafter, the Foehn. This is the hot dry wind in the Alps mountain. Khamsin, hot dry wind in Egypt. Sirocco, hot moist wind from Sahara to Mediterranean Sea. Mistral, very cold wind blows from the Alps over the France. Punas, cold dry wind blowing down towards the western side of Andes. Solano, hot moist wind from Sahara towards the Iberian Peninsula. Harmattan, hot dry wind blowing outwards from the interior of the West Africa, also called the Goenia Doctor. Bora, cold dry wind blowing outwards from Hungary to the north of Italy, near Adriatic Sea. Blizzard, very cold winds in the tundra region. Purga, these are the cold winds but find in the Russian tundra. Okay. Levanter, these are the cold winds in Spain. Nor'wester, hot wind in New Zealand. Santa Ana, hot wind in South California, USA. Thereafter, now we have the cyclones. The cyclone is the rapid inward circulation of air masses with a low pressure at a center. And it is anti-clockwise in the northern hemisphere and clockwise in the southern hemisphere. Like you can say, this is the cyclone. In cyclone, the center having the low pressure, that's why the wind from surroundings try to converge at that particular center. Okay. And that converts the cyclones. Okay. The direction is anti-clockwise in the northern hemisphere and clockwise in the southern hemisphere. Okay. Thereafter, the anti-clockwise. So anti-clockwise is a rapid outward movement of air masses with a high pressure at center. Okay. It means that that's how the flow is going on. All right. And this is having the reversible condition. It means it is clockwise in the northern hemisphere and anti-clockwise in the southern hemisphere. Then comes the hurricane. So hurricane or the tropical cyclones, these are the disturbance of about 650 kilometers across, spinning around a central area of very low pressure. Large oceans, waves, these are caused by the sudden motion on the ocean floor, and these are called the tsunami. The motion could be an earthquake, okay, volcanic eruption, or underwater landslide. Any of them could be there. Now we have the sources of water in the world after their wind system. So the oceans are the major source of water, okay, and they cover at least 71% of the Earth's surface. That's why Earth appears blue from the space. Ocean contain roughly 97% of the Earth's water supply. Okay, here you can see this is the flow chart also. Major ocean of the world, Pacific. Largest and the deepest ocean, Mariana Trench. The world's deepest trench is also found in Pacific Ocean. Atlantic. It is having the longest coastline. It is also the most busiest ocean used for trade and commerce, since the sea routes connect the two most industrialized regions, Western Europe and Northeastern United States of America. These two are the world's most industrialized regions, and these two are connected by the Atlantic Ocean. That makes it busiest ocean route for trade and commerce. Atlantic Ocean is still widening, and the Puerto Rico Trench is the deepest point of this ocean. Thereafter, Indian Ocean. Indian Ocean is the only ocean of the world that is named after the country India. It is deeper than the Atlantic Ocean, and Java Trench is the deepest point of this ocean. Arctic, the smallest ocean and lies within the Arctic Circle. This is an Arctic Ocean. Most of the part of ocean is frozen because it nears the pole, and hence it is saline and the shallowest among all the oceans, and Litki Deep is the deepest point of this particular ocean. Now, rivers. Rivers are the another source of water on earth. River is a natural flowing water towards ocean, sea, or another river. Bottom of the river challenge is oftenly called as bed, and the sides of the channel are called the banks. Okay. If we talk about the major rivers of the world, Nile, tributaries of Lake Victoria, Africa, and it's the longest river of about 6,650 kilometers. Amazon, glacier-filled lakes, finds in Peru, largest river and second longest river by 6,400 kilometers. Mississippi, source of red rocks, this is the longest river in the USA, Montana. Yenisei, Tenuola Mountain, Western Tuva, Russia. Largest river system flowing to the Arctic Ocean, like 5,540 kilometers. Zeri, Congo. Confluence of Lualaba and Luapala rivers, Congo. World's deepest rivers with major depths in excess of 220 meters. Nigeria, Guyana, third longest river in Africa of about 4,180 kilometers. Mekong, found in Tibetan highlands, world's 12th longest and Asia's 7th longest river of about 4,350 kilometers of length. Danube, Black Forest, Germany, second longest river of Europe and longest river of European Union, 2,860 kilometers. Volga, Volga Plateau, Russia, longest river of Europe, 3,530 kilometers. After this, now we have the waterfalls. So a waterfall is a place where water flows over a vertical drop or a series of steep drops into the course of a stream or river. Like this. Important waterfalls. Angel Falls. Location Venezuela. World's highest uninterrupted waterfall. Tugela, South Africa. Second tallest waterfall in the world. Jog Falls, Karnataka, India. Second highest plunge waterfall in India. Niagara, border of Ontario, Canada, New York. Made up of 3 waterfalls, therefore American Falls, Bridal Veil Falls, and Horseshoe Falls. Victoria Falls, South Africa. Described by CNN as one of the 7 natural wonders of the world. Now, important lakes of the world. Lake Superior, Canada and USA. Largest of the Great Lakes of North America. Victoria, Tanzania, Africa. One of the African Great Lakes and source of Nile River. Baikal, Nature's Lake, Russia. The oldest and deepest freshwater lake in the world. Malawi, Tanzania, Africa. Second deepest lake on the African continent. Great Bear, Canada. Fourth largest in North America. Thereafter the canals. Panama connects the Pacific Ocean with the Caribbean Sea. Suez connects Mediterranean Sea to the Red Sea. Erie connects Atlantic Ocean to Great Lakes. Kiel connects North Sea to Baltic Sea. After this, we have the major islands. Okay. Greenland, country Denmark, world's largest island. New Guinea, Indonesia, world's second largest island. Borneo, Brunei, Malaysia, Indonesia, third largest island in the world and the largest island in Asia. Madagascar, country Madagascar, fourth largest island in the world. Baffin Island, Canada, the largest Canadian island. Sumatra, Indonesia, the largest island in Indonesia. After this, now we have the natural vegetation. The natural vegetation refers to the plants which have grown naturally and not planted by the human beings. Three major types of natural vegetations are the forest, deserts, and grasslands. Forest can be classified as tropical rainforest, temperature deciduous forest, and temperate coniferous forest. Deserts are arid or dry regions and receive less than 100 inches of rainfall. Please correct this. That will be cm, centimeters. Okay. And the world's deserts occupy almost 1/4 of the Earth's land surface. Now we have the famous deserts of the world. Sahara, also known as Libyan Nubian. North Africa, largest, hottest desert. You can see it here also. Victorian, Great Sandy, Australia, largest desert in Australia. Arabian, Rub al Khali, Arabia, second largest desert. Dasht-e-Lat, barren desert, Iran, largest salt later. Dasht-e-Kabir, also Iran, salt desert. Atacama, northern Chile, driest known polar desert. Patagonian, Argentina, largest desert in Argentina. Kalahari, Botswana. Namibia, oldest desert in the world with 55 to 18 million years ago it was existing. Now, what are the grasslands? Grasslands are area dominated by grasses and have few or no trees. Grazing and roaming animals occurs in abundance. They occupy 1/4 of Earth's land area. Famous grasslands of the world. Steppes, Eurasia. Prairie, USA. Pampas, Argentina and Uruguay. Veld, South Africa. Downs, Australia. Canterbury, New Zealand. Now we have the mineral resources. So, what do you mean by the mineral resources? A naturally occurring substance that has a definite chemical composition in a way is called a mineral. Minerals are not evenly distributed over Earth's surface, and that they are concentrated in a particular area or rock formations only. So that's why their quantity and availability differs from world to world. Sorry, country to country, not world to world. Okay. Like the mineral, leading producer. First is gold, South Africa. Bauxite, Australia. Copper, Chile. Platinum, South Africa. Chromium, South Africa. Vanadium, China. Antimony, China. Tungsten, China. Phosphate, Morocco. Manganese, South Africa. Diamond, Russia. Iron ore, China. Petroleum, the USA and the Saudi Arab. Now, if we talk about the mines of the world, so Kimberley, South Africa, famous for diamond. Lumbabashi, Zaire, famous for copper. Wenke, Zimbabwe, famous for coal. Witwatersrand, South Africa, famous for gold. Katanga, Zaire, Zambia, famous for copper and cobalt. Kasai Province, Zaire, famous for both diamond. So students, basically in this lecture, we have finished the physical and the world geography. In the next lecture, we will start with another topic. Till then, just revise the facts and figures that all we have discussed in this lecture. Be ready for the next lecture. With this note, let's end this lecture and thank you.